So we're gonna throw a baseball, I guess. And you guys have been quiet in the back. So what's the speed of the baseball we're throwing? We're throwing a baseball. What speed? 72 miles per hour. All right. And that's a good throw. And what angle are you throwing it at? Okay, that's it's an easy. All right. 0.707. So you're throwing this, and how high is the cliff this time? You. Okay. 200, is that feet?
Yeah.
Okay.
No, meters.
Meters? Oh. 246 feet it is. All right. Oh, it's all right. So, and yeah, you can put conversions on a sheet if you need.
Do I need to put it?
How it is, if you need a conversion, you can ask. I may give you some weird one, but you
It's gonna be like the border set all over again.
Oh, that was these ones are pretty straightforward. They're the not like I used to put like something about like acreage and hectares. All right, so what do we want to know? Do we want to know how far away the ball lands? Is that okay?
Yeah.
Okay. The cool thing is you can't find this without knowing the time.
Awesome.
Right? So we want to know, oh, this is going to land like somewhere over here. So they throw this thing really far. Okay. So we know this. We know this is what we're told. We need to find delta x, how far away it lands. So what are things we know, or what are things we have to do now to set up our problem? We have to find our unknowns. That's true. But as we set up, so they tell us that, you know, someone stands on a 246-foot cliff. They throw a baseball at 72 miles per hour at 45 degrees. How far away does the ball land? That is the question as it is written on the exam. So you sketch up this cool diagram on your test. What else do we have to include? What else do we need to do before we can even pick an equation to start? What other information is given to us that was not told to us, but we're supposed to know?
It's 0.
AX is 0. Yes. Yes. And someone I mentioned already, you have to split things into components. Thanks, chat. All right. So we also know what other acceleration. Okay. Y is 9.8 meters per second squared, and it's down. So next up, we need to get the components, as someone mentioned. So what do we have to do before we can get components, though? Convert. So 72 miles per hour needs to be converted to meters per second. So to do that conversion, we remember that 72 miles per hour times 4/9 gives us meters per second. That is right. 8 times 4. So now what can we do? Now that we have that, we can get our. You okay?
Thank you.
Oh, okay.
We can convert the feet.
Yeah, we can convert the feet to meters as well. Well, it's another conversion we'll do. And we remember that 246 feet times 0.3048.
How do you know that off the top of your head?
It's his job. No, like you do these things enough times. You remember that, right? And you should get something close to like 8. thing. 80 plus 8 is 20. Okay. 0.98?
Yeah.
I'm gonna go 75. That's as high as the kid we picked before. Unknown. Small world. All right. So you notice your friend is throwing pumpkins straight up further down. All right. So we're gonna throw this baseball. Now we need to find what? VI X and VIY. So VIX is VI cosine of our angle, and VIY is VI sine of our angle. So this is going to be 32 times the cosine of 45, and this is 32 times the sine of 45. It's like 21 plus, it's 22. What is it? 22 point what? 6. And that's the same for. This is that magic angle that sine is close to. Just like 36 cubic complex. The sines and cosines switch on. Strange things. All right. So we now have our components. What's next? What else did we not label on our picture, but we do now? V top is 0. So we know not just V top, Dy top. And that's a magical location called Y max, which we don't know. And technically we could solve the problem. So so we then pull out our one equation in the X, and we're like, delta X is VIX T. Right? And by T, we'll just do here, and we'll say that's T. Right? This is question 1. So we're like, man, we can't use our VIX equation. We can't use this yet because we don't know T. Is everyone good with that? So what should we do? We have 2 choices now. 1, you can find T up and T down to find T. Or you could use the quadratic equation and find T right.
Let's try the quadratic.
You want to try the quadratic? Okay. So when we look, we know the following. We know that delta Y is equal to VIYT plus 1 minus 1/2 G T squared. And this is a very powerful equation because as long as you know certain things, if you know the initial condition of launch, you can solve this object's location anytime going forward. All right. So let's take a look. Delta Y. This is Y final minus Y initial. 0 minus 246 feet equals DIY is 22.6 times T minus 4.9 T squared. And now you just solve the quadratic equation. Right? Because you move the 75 over and you have 0 equals negative 4.9 T squared plus 22.6 T, plus 75. So this is your A, your B, and your C. So you have the opposite of B plus or minus the square root of this number squared. I'm going to actually do this on the next board. Sorry. Come on, people. All right. So let's start over. So there's our A, B, and C. And then what we'll do is we'll go the opposite of B plus or minus the square root of B squared minus 4 times negative 4.9 times C all over 2 times 9 negative. So we have minus 22.6 plus or minus the square root. It's like 4. 444, something close to that. I made up a minus 9.8. This is about 7. Rough. These have calculators. You can find them. Otherwise, I'll just keep making. All right, over negative 9.
Squares.
590,
510.
510. Okay, I'll take that. Thanks. I can update the real numbers. That's 12. Oh, that's even better. That's close. Square root is 12. It's close to 12. So this is like 35 square root. How did you get 750? I made up the number. 1470. Okay. Oh, 16. I doubled that. That's why. Okay. You said 1470. It should have been 1500. I multiplied by 4. Okay. Cool. That's even better. That's the square root. That's 40. These have calculators. That's 1980s. Okay, so we have minus 22.6 plus or minus 45. Yeah, okay. Over negative 9.8. So now we have 2 solutions. All right, so this is, one of them is to go minus 22.6 plus 45 divided by negative 9.8. And there we go. And then the other one is minus 22.6 minus 45 over negative 9.8. So this is like, this will be a negative number, right? Because this is like 22 divided by 9. What was this one?
Negative 2.24.
Negative 2.24 seconds. And then this is negative 68 divided by 9. 6.85. So now notice we have 2 solutions. And why do we come up with 2 solutions? Well, let's take a look at our picture real quick. So negative 2.2 seconds is right here. Negative 2.2 seconds. So all the equation does is say, hey, if I ran backwards this way, my ball will cross y equals 0 over here at negative 2. It just runs the projectile, it runs the parabola backwards, right? Now, the other option makes a little more sense because this is forward in time at 6.85 seconds. Right? And that's over here. So the other option is to run the parabola forward in time, and then you have minus 22 minus 45 is negative 6, roughly negative 68 over negative 9.8, and that gives you all the negatives cancel to give you a positive time. And you have to use positive time because the arrow of time is good. So this is our time to get here, and now we can solve the problem, right? So now you can solve your problem because delta x is 22.6 times 6.85. That's close to it. Okay. Now, what you should do just one time so you know, you should find time up, time down, add them up and verify that it's 6.85. And that way you know that you can trust whatever you do with the quadratic equation. Right? If you wanted, it does save a little bit of time, but a lot of times they'll also ask you, if they ask you for y max, you still then have to solve this half of the problem. Right? So it's your comfort, how comfortable are you with the quadratic equations?
Very comfortable now. I read it now.
Okay. Yeah, that's something if you want to put it on your equation sheet, you can. If you didn't have to memorize it.
We had to memorize it. She gave us a song. But
Oh
like,
yeah, there's a song.
you can put in any variable to the tune of the song, so it's not easier to remember.
I remember somebody made a story about it. Very
Negative b plus or minus the square.
and then the bee flew up and down. Then it came across a root in the ground, and it had to go over the root. And then there was a whole story about this bee flying around. I don't know. I brute forced it. So, all right. Are you good with whoever? Oh my gosh, let's check. Let's see if I can scroll up. L is L good with that problem. Okay, cool. And then you have to be able to do that under. That's one thing to think about on the test tomorrow. You do need to kind of have a plan because you do only have about 50 minutes, right? So you need to think about, about 1 minute per multiple choice, and then that'll give you about 10 minutes per extended response.
So like the incident response, are those like pretty much all just longer math problems? Is there any like writing, like explanation kind of problems too, or just longer?
They're just word problems,
Okay.
right? Where you have to pull out numbers and write out equations.
I don't know if it was like explaining.
If that came in, like picking things off graphs would be like the multiple choice.
So we go over conceptual that you.
I would say, without loading in Google Drive. Let me see. I was gonna say we can go over the ones we did in class. Would that be okay? Okay. Sorry, let me get into Google Drive. Oh, you'll find out tomorrow. You don't have to wait a day. How exciting!
That's where you're
You shouldn't be worried about it. It's exciting.
true.
Now, those are only on the extended response.
Oh, okay. Done the whole thing.
Nah.
Well, I mean, if it's like what's the name?
Oh, you'd be surprised. If I really wanted to, you'd be surprised.
Sorry, yeah, I guess because
Alright, so we're on the fall 23. This is where you exist. I think we should open the Google Slides. Oh, hold on. Sorry, I'm getting ready to share some stuff. I think a lot of people left. All right. This final? Oh, yeah.
Different anime, how.
Oh,
That's really fun.
yeah, because our finals are cumulative. Is you aware? How do you know such things?
Starting like an elevator,
All right.
like backwards.
All right, so Do you recommend doing extended response first or the multiple choice first as far as time? I think you should read through the multiple choice first and answer each one you can as quickly as you can. And then do the extended response and then go back and finish up the multiple choice. That's what I would do. Like when I took tests, just answer every multiple choice you can the first time through as quick as you can to get every